Okay, ladies and gentlemen, so what I want to do now is finish off our work in Chapter 6, Introduction to Quadratics, and we started this and almost finished it yesterday. So on post number 17, I think it is, we have the videos for 6.1 all the way up to and including 6.4 completed, and that was all done yesterday. So all of this. What I want to do now, though, is because I have a different cohort in front of me, is I want to review it. So I'm going to go to the back of the package. Everybody has this, and we're going to take a look at the review of Chapter 6. Now, if you don't have these, check back. You should. Everybody received a copy that was in class, and if not, then you can download it from the post 17, I think it is, the one where we did those lessons. So let's take a look at what we have here. Zooming in maybe so that everyone can see what I'm doing, checking that things are set up properly, and off we go. Answer the following questions in full sentences and explanations. So, what is the difference in the graphs of a linear and a quadratic relation? Well, the differences are a linear relation creates a line as a graph. And it has a constant slope. Now, that's different than a quadratic. A quadratic relation creates a parabola. Now remember, that's how you say that, parabola, not parabola. So that's a parabola. It creates a parabola when it's graphed. And remember, that's a U-shaped object. That's an object that looks like this. Or if it opens down, looks like that. And it does not have a constant slope. It changes. The rate of change changes in this one. So it does not have a constant rate of change, which is what makes it very different. Not having that constant rate of change is what creates this nice little curve. And that's what I'd be looking for if I gave you a question like this on a test or an assignment. Oh, by the way, you have an assignment posted for this unit, so this lesson's going to help you with that. So hopefully go over this and then find out where your assignment is and start working on that. And that assignment is due by noon on Monday. So you've got 2 assignments that are posted right now, one for Chapter 5 and one for Chapter 6. Make sure you get those in. So B, what is the difference in the finite differences? The first differences and the second differences of a linear relation and a quadratic. Well, for a linear relation, the first differences are all the same. And that's where you stop. Because once you figure out that the first differences are all the same, you know that you're dealing with a linear relation. However, a quadratic relation does not have the first differences all the same. I'm going to use DIFF for the short form for differences. does not have the first differences all the same, but does have the second differences all the same. And we went over that quite well in the videos previous to this one. So in the post before this one, we went over exactly what that means and how that shows up. C, what is the difference in the equations? Well, a linear equation looks like this. And a quadratic equation looks like this. And the difference is the degree of the variable term. Now we call this a degree 1. It has an invisible exponent of 1, so it's an x term. And this one has an x squared term, and we call that degree 2. So the thing that makes it quadratic is this term, this ax squared term. That's what makes it quadratic. The fact that this doesn't have the ax squared term means that it is only linear. So it's this x squared term that makes all the difference. It's what changes it from linear to quadratic. Okay, moving down. Label the following features on this parabola. Well, the parabola is this. It's the U-shaped curve. All right, so that is the picture of the quadratic relation, the equation. I don't have the equation here. I don't know what it is. A general equation is to say ax squared plus bx plus c. That's a general equation where the a, the b, and the c's will all be numbers. Okay? So the a, the b, and the c are all numbers. And this is what it looks like. It's a U shape. And the U shape can either open up or down. And in this case, it opens up. Now it says there's some parts on this U shape that we need to know. We need to know their names. We need to know that this point right here on the y-axis is called the y-intercept. And as a coordinate point, it would be given by 0, comma, whatever this value is. Hello. We also have what's called x-intercepts. Well, x-intercepts are on the x-axis. And it's where the equation, or where the parabola, crosses the x-axis. So this is an x-intercept. And this too is an x-intercept. And those x-intercepts will always occur wherever y is 0. So it's going to be x comma 0 and x comma 0. Interesting to note that a parabola can have two x-intercepts, but it will always only have one y-intercept. Think about that. If I move this parabola around, I can only ever cross the y-axis once. However, if I move this parabola up, so it's above the x-axis, I could get rid of all the x-intercepts, couldn't I? And if I moved it up so it just touched the x-axis, I could give it one x-intercept. Or if, like this, Then it has two x-intercepts. So there's more variety there. There's some other things that we need to know that are specific to a parabola. The point where it changes direction. So if we look at this parabola moving left to right, so going this way, left to right, then you'll notice that the parabola, the y values become lower and 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 lower until it hits this point here. Then all of a sudden it changes direction and starts going up, 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 up. This point where it changes direction is very, very important. And we call that the vertex. Very, 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 very important. That's the vertex, and it's the place where it changes direction. Now the vertex can either be at the bottom, or the vertex can be at the top if it opens down. When it's at the bottom, we call it a minimum. We call it a minimum because it's the lowest it can ever be. Every other point is higher than it. Does that make sense? I think it does. And if it opened the other way around, if it looked like a hill, then the vertex would be at the top of the hill, right? And that would be the maximum, right? Because that's the top of the hill. Everything else can be below it. So we have a vertex. We also have to talk about something called an axis of symmetry. The axis of symmetry is the line, the vertical line that cuts right through that vertex. And it's called an axis of symmetry because, look, the parabola is symmetric on both sides of the line. It's just flipped over. It's like a reflection. So we call that symmetric. And these are all the important points on any parabola. So a parabola has the following important features. It has x-intercepts, it has y-intercept, it has a vertex, and it has an axis of symmetry. There's something else. There's a direction of opening. Which direction of opening would you say that this parabola has? Does it open up or does it open down? It opens down? I disagree. Yeah, we would call that, it has a direction of opening up in this case. And if it was turned the other way, it would have a direction of opening of down. Stop the video there and I'll be right back.